Okay, so we're going to go over logarithmic functions. We're just going to go over the graph of one, and specifically log 10. Just to go over the relationship, if we have an exponential function, right, whatever that exponential function is equal to is the equivalent of log a being our base, so that base, to the answer is equal to x. Okay, so that's how these relate to each other normally. Now, when we go to graph the log, we're going to be looking at actually the inverse of what's usually shown as an exponential function. So they've drawn a little graph here for you, and it somewhat looks like this. Okay, so normally an exponential function roughly has this type of shape to it. It hits its base number, whatever it is, and then it takes off, right? That's how most of our exponential functions work. They always cross through 1 here. This is when x is 0, and then they take off. And that's usually will denote as y equals ax, okay, like we had above. Now your logarithmic function is going to be similar. It's going to hit our x value of 1 and take off. So you can kind of think of it like being the inverse. If we were to flip this on a 45-degree angle, the inverse of it. Now, its relationship to what we've just drawn is written as y is equal to log ax. Okay, a little different from the normal relationship we're trying to solve using logarithmic functions. Okay, it's considered almost like the inverse. Now, we're going to specifically look at log 10, and we're going to investigate what this graph looks like, and then we're going to go through transformations of it. So we'll quickly make one, and it just so happens when going through these graphs that they take off very quickly. So we're going to focus on when we're kind of around the number 1. Okay, so we'll call this 12.5, 75. We'll call this 1. Okay, and this will kind of be like 0.25. This will be 0.5. Okay, this will be 1.5. This will be 2. Okay, and we'll just kind of write our y values in as we go. So our function is going to be like this, and we're going to use log. So we're going to have y is equal to log 10. So it's kind of like our base 10. Okay, when x is a value. Okay, so the very first thing we're going to look at is when x is 0.5. What is our y value going to be? So we'll type it into our calculator here. There we go. So the way I type in my calculator is actually that when x is 0.5 was log 10. Negative 0.3. Okay, so that's what we got as an answer, negative 0.3. So what I'll do is, I guess we'll just move a bit, yeah. We'll call this 1. These will go up by 1, 2, 3, and it's really going to take off. So negative 0.3 at 0.5 is somewhere probably about here-ish. Okay, that's when we're at 0.5. And the more we go down, so another one we actually might want to look at, since I have room on the map, what I'll do is I'll move this down. We'll actually look at 0.25, just a little before that, to see what kind of a difference there are. So we'll also look at 0.25, which would be roughly here on the graph, right? Since this is 0.5, this must be 0.25. So we'll plug that into our calculator. Same idea, 0.25 log 10, negative 0.6 roughly. So a little, actually that should be down here more, and the red one should be up a bit. We'll move that red one a little, because it was 0.3 we said, right? So negative 0.3, this is negative 0.3, this is negative 0.6, so negative 0.3. Nope, that's the 6, yeah, negative 0.3, there you go. All right, this will be at 0.75. So let's take a look at where that log would be, essentially. We're looking at 0.75 log 10, negative 0.125, so probably somewhere like here. Okay. So we're talking about negative 1, 2, we'll call that. And then log 1. Log 1, it's going to be a little easier to think of, because think about it as our base 10s, okay? So if I have the number 1, base 10 is 0. That's because these are essentially giving us our powers, okay? So this is here at 0. So at 1, or when our x value is 1, our y value happens to be 0. Okay, we'll continue with that. We'll jump up to 1.5. just to see what that y value is. It's just so we get an idea of what the log graph is going to be, okay? And we're going to see how it changes. Well, 1.5 log 10 is 0.17, so pretty low here, okay? And we'll jump ahead again to 2 log 10, 0.3. So you noticed here it's not as large of a change here. This one was, what did we say it was? 0.3, right? So this one was
0.17.
Yeah. 1.17. This is 1. Oh, sorry. 0.17. Yeah. And this one's 0.3. This one is 0.3. Okay. So essentially what we're kind of estimating is it's going to go here past 1 and then it's really going to take off. Okay, before we can find our y value. And here it's going to get very close to our y-axis, but actually never touches it. The reason I showed you these ones here is because as we go farther and farther up this way, it's still going to be very low numbers as we go through it, okay? And these ones are going to change. So this is roughly our graph. A major point to notice is it does go through 1, okay? And that reason being is, think of this as if it's our base, okay? If that was our base, okay, and this is our y value, our y value is 0 when our x value is 1. We have to relate these back to our exponential functions, right? So if we have base 10 to the power of 0 is actually equal to 1, right? So in other words, this is where normally our x value is, and this is where normally, in this case, our y value is going to be up there, okay? So that's how they kind of relate to each other in terms of an exponential function and this log, right? If our y value is 0 in this case, then our x value must have been 1. Our answer must have been 1. And that's how these values are relating to each other when we plug them in. So then from there, we're going to talk about transformations of the graph. Well,
Wait, do we have to draw the exponential all the time?
You don't, no.
Oh.
You don't have to. It may help to go through that stuff, but you don't have to actually draw it. And that's when we have positive values, right? And if we have negative values, it actually changes the graph. Our logarithmic is going to change quite a bit. So let's actually go through that maybe also. Okay, so let's go on to like a word question that kind of attaches to this when we're translating our logarithmic functions. They've given us quite a bit of information. So what we're going to do is try to just relate our factors to each. We are vertically compressed by a factor of 2/3. What deals with vertical compressions? And I'm going to quickly write our formula above. A log 10 kx minus d plus c. So what deals with vertical compressions?
The A.
A, that's right. So our A factor, this is, oh, shouldn't have there. This. So A is going to be equal to, and it's pretty simple, 2/3, right? Because a compression is a number less than 1, and 2/3 is less than 1. Perfect. Horizontally stretched by a factor of 4. What deals with that? The K. K deals with that. What is our K factor going to be?
1/4.
That's right. It's stretched by a factor of 4. So, in other words, we actually have to divide our value by 4, so it's kind of like the reciprocal of A. Okay, so because it's been stretched by a factor of 4, it's 1/4. Had it been compressed by a factor of 4, it would be times 4.
So just 4.
Yeah, just 4. Yeah, exactly. Reflected on the y-axis. Which one reflects on the y-axis? K does. K flips it from left to right. Oh, did you? Okay. K does. So because it flips it from left to right, that means our K value is going to be negative. So in other words, we're actually going to have K, well, let's put an arrow. K is equal to -1/4. Okay, that's going to be important in this part. A vertical asymptote, that's important they worded it that way. A vertical asymptote at x equals -2. Yeah, that's right. That's going to deal with our d value because we're going to be horizontally translated which way?
To the left.
Yeah, so we're going to go to the left 2 units. So now I know technically you plug in -2 and you'd have a negative of a negative. Tell me what this operation will be in front of d.
Positive.
Yeah, it's going to say +2. Now technically you are plugging in -2. Because it's going to say, x minus -2. And that's what creates the x plus 2. Okay, so that's where we get the operation of +2. And finally, translated 3 units down. That's going to be our C value.
Minus.
Yeah, and because we're going downwards, we're -3. So let's plug in our values here. Y is equal to, we said A is going to be 2 over 3. Okay, still have log 10. We've now said that our K value is going to be what? -1/4. Good. We still have X. Plus 2 is going to be our D. And then our, and then our C is -3. Great. So there's our formula. Pretty straightforward. What would this graph essentially look like? So let's try to throw together a little makeshift graph here if we can. Okay. We'll try to draw the original again as best we can. I guess we'll go by ones. Now, actually, since we're probably going to go into the negative values, let's kind of move our y-axis to the middle here. Okay. Now, normally, our log function, this is our 1, 2, 3, 4, 5, right? So this is -1, +1, 2, 3, 4, -1, -2, -3, -4. So we're going to try to draw a rough sketch of this. Our original one, if it was just y equals log 10, we know we'd cross our x-intercept would be at 1. We'd have a vertical asymptote at 0, and it would essentially be doing something like this, right? It's taking off from there. Now, what's happening? First of all, our vertical asymptote has been shifted 2 to the left. Okay, so think of our vertical asymptote itself, which I'm going to just put in red here. Okay, this vertical asymptote has to go over 2, so now it's at -2, which then means that our x-intercept, we'll do it in green since we're talking about this specific, this x-intercept has to move over 2 also, so it goes over 1, 2 values. So our new x-intercept's at -1. Okay, our new x-intercept is at -1 for this case. Our other function here, and what's going to happen is it's been shifted how many units? 3 down. Okay, so because the whole thing's been shifted 3 down, our vertical, our x-intercept is actually going to drop 3. Always think of it from the x-intercept as the point to move from. So we're going down 1, 2. Should have made the graph a little bigger for this matter, but 3. Okay, so that would in itself, let's go to 100 so we can see a little more of this. Yeah, that would in itself, that would be just the horizontal and vertical stretches. Okay, so we'd now be coming through here, something like this. Okay, so things have changed here. We've dropped this down 3 units. Okay, so that's how we know to move our, it's like, almost think of it like a vertex of a quadratic. That point, that x-intercept is where we're going to move from everything. Okay, so we move that over, and now we have to talk about, we'll talk about the A stretch and then K, because that one's going to be a bit tricky. We'll do that last, and how that affects our asymptote. So we're actually shrunk. So in terms of it, think of it, if we were at the original one, okay, it's actually shrunk a little. So it would be a little higher up than the parts that are below 1. It would still cross here, but it'd be a little bit lower than our original. That would be if just A was 3 over 2 and there were no other changes. Okay, so in other words, from what I got here, I'm going to have something that does roughly the same thing, and it's just a little compressed in comparison to it. We're not going to pick those exact values because, like I said, they're decimals. They're going to be tougher to work with, right? So that would be our A, and now K. We're going to talk about K because it can be tricky. Okay, so we just talked about our A movement here. Now, K is tough. First of all, because K is negative, the entire thing now has to move to the other side of the vertical asymptote. So this was our like key point here at 1, right? So let's just assume this is just the flip of the 1. When we flip it to 1, it becomes -3. That's essentially, that's 1 unit to the right of the vertical asymptote. This makes it 1 unit to the left of it. Okay. Now the other thing was, let's think as if we were back in our original one. If we were with our, when we just flipped K, we would have an asymptote here, and we'd be actually facing this way as we go through it, okay? And we'd be hitting our -1. Well, since it's a horizontal stretch of a factor of 4, it would pull this out to 1, 2, 3, 4. Think of it like -1 times 4. So that would be our new vertical asymptote, our new x-intercept. Our vertical asymptote would still be here, so it would be pulled this way. And then because the vertical asymptote shifted twice, it would move this over to -6. Okay? And now we talked about how -3 up here, we pull it down -3. So from -6 we go down 1, 2, 3. That's how this blue point here technically ends up way down here. Okay? I know that's a bit confusing to look at. So then really what we have is something that's going across, hitting there, and going up. Okay. Really, they just wanted us to make the equation, but that's what our graph would look like when we go through it. Okay. A lot of stuff. It's true that now this is strictly for when our a value in our log, so in other words our 10, we've talked about 10 is greater than 1, it'll look like this. And there's options when it's less than 1, but because we're focusing on log 10, we really just want to pay attention to this investigative graph we've drawn right here. So what we're going to go from there is we're actually going to go into some transformations of it. Now, our function, we usually write it as here, y is equal to a, and then we have our function itself, which is log 10, k, x minus d plus c. Now this is all familiar to us because these deal with vertical stretches and compressions and flips. So we'll call them flips, that's when it's negative, stretches when it's greater than 1, and compressions are when it's between 0 and 1. Does that make sense?
It's it reflects on the y-axis?
Yeah, reflecting on, no, this is reflecting on the x-axis.
Okay. So I always get that mixed up.
Yeah, this reflects on the x-axis. Think of it like flipping it up and down, and so I have those arrows there, okay? Our k is horizontal flips, stretches, and compressions. Their difference is this flips on the y-axis, okay? A stretch is actually when we're between 0 and 1, and a compression is when a is not a, but k, when k is greater than 1.
It's the opposite of
Yeah, it's the opposite of the other one, when k is greater than 1. So this is when k is between 0 and 1. That's when it stretches, okay? Our d, which I guess we'll do in green here, or our horizontal shifts left and right, okay? So think of it, if it's like a negative value, we actually go in a positive direction, and if it's a positive value, we go in a negative direction, okay? And finally, C, again, deals with vertical. This only difference here is when it's positive, it goes up, and when it's negative, it goes down. It's pretty intuitive, okay? So since we know from our graph above that we have a vertical asymptote at 0, okay? That's very important. This line will never touch it. It'll just get extremely close to it, okay? And this one will just continue to go up, 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 depending on what number we're at. We'll talk about actually a value here. So let's say they've given us something in this example, -2 log 10 x minus 4, right? They've given us this value here. So we're just going to quickly jump through it. Do we have an a value?
Yeah.
What is
-2.
Yeah. So right away, because it's negative, what's it going to do?
Reflection
Okay.
on the x-axis.
Yeah, reflect on the x-axis. So it's going to flip, and it's 2, so what's it going to do?
Stretch.
Okay, so I put F for flip and S for stretch, okay? Do I have a K value?
No.
No.
Oh,
Well,
1.
yeah, I think of a 1, which means it doesn't do anything, right? Do I have a D value?
Yeah, 4.
4. So which way is it going to move?
Right?
Yeah, it's going to move to the right. And do I have a C value?
No.
Well, technically I do. What would it be?
1.
Not 1.
0.
0. If it was 1, I'd actually move it up 1. 0 means I'm not going anywhere with it. So we're not going to move up and down anything, okay? So in terms of our original one, let's say we quickly graph this. I'm going to make the graph up quickly as we go here. Because it's got a horizontal movement, I'm going to just go by 5s, let's say. Okay, so we have 5, 10, 15. Actually, you know what? 2s might be good to go by. Let's go by 2s. Let's change that a little. We're still going to go up by 1s. Okay, so 1, 2, 3, 4. Your scale can be whatever you really want. 2, 4, 6, 8, 10, 12, 14. Okay, not that is important. Now, our original log, let's say we had y is equal to log 10x. Okay, that original one goes through 1, we know. It comes up like this and gets pretty flat. That's the general idea of it, right? We know it's going to hit at the value of 1. And we have a vertical asymptote. Well, at our original one, we have a vertical asymptote at 0. We have one coming through here. Now, because this is 4 and it's moving us to the right, 4, our new vertical asymptote, we'll do it in green just to relate it, is going to be at 4. Okay? Also, what that means is we're moving, this 1 is going to move over 4 units. So it goes over 1, 2, 3, 4 units. Where are we now? Where is its x-intercept?
4.
It's not at 4 because it's a
5.
5, that's right. We have a x-intercept at 5. Okay? It doesn't move up and down any. We've taken a look at that, right? We don't have a c value. It doesn't move up and down any. We now have a new x-intercept. It is going to stretch, though. Now, the stretching is a little harder to quantify when going through this. It can be done. But what's really important is it's going to flip. So it's no longer going to be coming from down here because we're flipping on the x-axis. Think of it like it would be coming down from here and doing this, okay, because of that flip. Well, because we had to move it over to the right and our new x-intercept is at 5, it's going to be coming down to 5. And it is stretched by a factor of 2, so it's a little bit higher than the other one would have been, okay? So this is what, I guess I should do that one in a different color. Let's do that. Well, since we like this with blue, so it's coming down. It hits our new x-intercept and is a little bit stretched compared to this one over here, okay, because it has been stretched. Now, those specific values are really hard to memorize. And you might want to think of 1 or 2 of them, but just the general idea is it's longer than it was before, okay?
Wait, so how did it